Okay, we're going to look at circles A. This is we're going to be working with arc length and sectors. Here we have a sector of a circle with radius 5. So let's fill that in right there. The radius here is 5. And we've got to find the area of the circumference, and this stands for the measure of the central angle. So that one we get right away. The measure of the central angle just means it's 135 degrees. No big deal. Okay. The area of the overall circle is, again, pi times the radius squared. So if the radius is 5, we take 5 and square it. 5 squared is 25. So the area is going to be 25 pi. Wouldn't you know it? Wouldn't you know it? 25 pi. So there's your area. Okay. The circumference is going to be 2 pi times the radius. So again, it's 2 pi times the radius. If the radius is 5, 2 times 5 is 10, so the circumference is 10 pi. Okay, now what we're really after is finding arc length PQ. That's this distance here, and the area of this entire sector. All right, so arc length PQ represents a portion of a larger circumference. Now we already figured out that the entire circumference was 10 pi. So basically we're trying to figure out, well, how much of 10 pi is this? Well, it's 135 degrees over 360 degrees. So clearly we have to reduce this. One thing you can kind of understand, we'll move over here for a little understanding. Say that we all know that a 90-degree angle represents a quarter of a circle. Well, then it would stand to reason that a 45-degree angle would represent an eighth of a circle. So if every 45 degrees represents an eighth, if I added another 45 degrees right here, what I have is 45, 45, 45, that would make 135. In other words, 135 degrees represents 3/8 of a circle. 1, 2, 3, 4, 5, 6, 7, 8. So it's 3 out of the 8. So if 135 represents 3/8 of a circle, then what we need is 3/8 of the circumference to find this arc length. So if the circumference is 10 pi, what we can do is 10 pi over 1, of course, times 3/8. So that yields 30 pi over 8, which can be reduced to 15 pi over 4. And that will be our final answer. 15 pi over 4. Alright, so that's this arc length. Next is the area of the sector. Now, the area of the sector is the area of the circle times the measure of the central angle over 360. We already figured out that the central angle over 360 is 3/8. So we take the area of the circle, which is 25 pi, again over 1, and we multiply by 3/8. This gets us 75 pi over 8, which cannot be reduced. So that's the area of this sector here. Okay, so that's how these are going to work. This next one's going to work basically the same. The radius here is 3 square root of 3. So that's maybe a little less comfortable. It's not a whole number, but shouldn't be too big a deal. If the area is going to be pi times the radius squared, well, that gives us pi times 3 square root of 3 squared. So let's square this number. 3 squared is 9. Square root of 3 squared is 3. So the whole thing equals 9 times 3, or 27 pi. That's the area. The circumference is going to be 2 pi times the radius. So if the radius is 3 square root of 3, then this will be 6 square root of 3 times pi. Okay, no big deal. And the measure of the central angle here is 30, meaning that we have a 30-degree sector and a 30-degree arc of this circle. So if I want to find arc length JK, what I do is I take the circumference, which was 6 square root of 3 pi, and multiply by 30 over 360, which is actually not too hard to reduce. Cancel the 10s right away. 3 over 36 equals 1 over 12. So what we've got now is 6 square root of 3 pi times 1 over 12. So put this here, that yields 6 square root of 3 pi over 12. The 6 and the 12 can reduce to 1 and 2, leaving finally square root of 3 pi over 2 for arc JK. Now for the area of the sector, we'll do the same thing, but now we're going to use the area. The area was 27 pi, so we're going to multiply that times the 30 over 360, which was 1/12. I'll put a 1 here. That yields 27 pi over 12. These are both multiples of 3, so what I'll do is I'll reduce like that. And I'll get 9 pi over 4 units squared. Okay, last one is this one. Here our radius is 4 square root of 2. So our area is going to be pi times the radius squared. So let's square this radius. 4 squared is 16. The square root of 2 squared is 2. 16 times 2 is 32. 32 pi units squared, because it's 4 square root of 2 squared times pi. The circumference is 2 pi times the radius. So if the radius was 4 square root of 2, then it will be 8 square root of 2 pi. Okay. Central angle here is 45 degrees. So in order to find the arc length, it's going to be the circumference, 8 square root of 2 pi, times 45 over 360. Now if we look back to here, we can remember that 45 is half of 90. In other words, half of 1/4 of a circle, or another way of looking at it, 1/8 of a circle. So the 45 over 360 reduces to 1 over 8. So 1 over 8 is represents our central angle over 360. I'll put the 1 there to keep it balanced. That of course gets me 8 square root of 2 pi over 8. These 8's cancel, getting me the square root of 2 pi. And last, the area of the sector. The area of the sector, well, the overall area is 32 pi. So what we've got is 32 pi times, again, 1 over 8. 1 over 8 representing the 45 over 360. I can put a 1 there, and that gets me 32 pi over 8, which reduces to just 4 pi units squared. Okay, nice and happy. There we go. Thanks a lot. Watch it a couple times. Good luck, and I'll see you on Monday.